Okay, so now we are going to look at how to compute cyclic redundancy check, or CRC. Now this is based on two things. One is polynomial and the XOR operation. So first of all, what's the XOR operation? So XOR is if you're given two binary bits, okay? So um, 0 XOR with 0, the two bits are the same, the two operands are the same, then the answer is 0. And if the two operands are different, so 0 XOR 1 is 1 and 1 XOR 0 is 1. On the other hand, 1 XOR 1 is 0. So this is what is the XOR arithmetic. The other thing you need to know is the polynomials. So the degree of this polynomial is 4, right? So in CRC we want the sender and receiver to agree on a generator polynomial. The degree of the generator polynomial is the size of the CRC. So in this case, a generator polynomial is of degree 4, hence the size of the CRC is 4. Okay. Now, so once the sender and receiver agree on this, so now we need to be able to write the generator polynomial in binary given its polynomial form like this. So that is written like this: the coefficients of each x term. So x to the power 4, the coefficient is 1, so this is 1. There's no x cubed terms, so the coefficient is 0. There's an x squared term, so coefficient is 1. There's an x term, and it's a constant. Okay. On the other hand, if you're given something like say something without even a constant, then the binary equivalent is this is x to the power 5, 1, there's an x to the power 4, there's no x cube, no x square, there's an x term, and there is no constant. So this is the binary equivalent of this generator polynomial. Okay. So now you should be able to do this XOR division. So given a message, okay, and it's generator polynomial, so I'll give you both of this. So the generator I could give you directly in binary like this, or I could give you the polynomial, and you should be able to get the binary equivalent of it. So the degree of generator polynomial is the size of the CRC. So this is a constant x term, x square, x cube. So the degree of this polynomial is 3. So the CRC is going to be of size 3 bits. So what we are going to do is we are going to write the message. So this is the message part, and add or append 3 bits. Why 3 bits? Because based on generator polynomial, the size of the CRC is going to be 3 bits. Okay, so we put 3 zeros. So that's like an initial estimate of the CRC, and then we are going to keep doing this division, and eventually end with 3-bit CRC. Okay, so okay, so write this thing, and then 1101, write it up, and then do a division. So it's like XOR arithmetic. So 1 XORed with 1 is 0, 1 XORed with 0 is 1, 0 XORed with 1 is 1, 1 XORed with 1 is 0. So when you get zeros to the leading left, you can just skip them, and then you rub. So you have only 110 from this XOR arithmetic, so you bring down a 0. So that makes you have 1101, and 0 XORed with 1 is 1. You don't you'll get zeros towards the left, so you can skip all of them and bring 1101. You have 1101, so that is all zeros now. So bring 4 more bits, and then write 1101. 0 XORed with 1 is 1. You get all zeros to the left. So then you bring down these 2 bits, and that's all you have, and you already have 3 bits. Okay, So these 3 bits is your CRC. So what you do is you send the message, this is your message, along with 3 bits of your CRC. Okay, so this will recompute the CRC for the message and see if it gets 100. Alright, now the only thing you have to notice, if there is something like if the message starts with a 0, the message starts with a 0 and you have something like this. Let's say this is a message and your let me see if I can show the division. Let's say your generator polynomial is the same thing, 1101. So how do you do the XOR arithmetic? So you put it down here, 1101. So this is going to be, if you do the XOR arithmetic, this is going to be 1000, right? So you have this 1 to the left, so you cannot bring down any more bits, so we'll use this 1101, and then if you do the division, it's going to be 0 now, and then 101. So now you can skip this 0 and I can bring down this one here, and that's going to be 1101, and you get 0110. So you can skip this 0 to the left and you can bring down this one, right? So that's going to be 1101 and it's all zeros, right? So how many ones we brought down? This one and this one. So the remaining, this 3 bits, and we have to append 3 zeros. I forgot that, right? So there are 3 zeros that we need to append because of CRC, because I told this is a message and we need to have appended 3 zeros, right? So these are our CRC bits. So let's bring this 0, 0, 0, 0, 1, and then this 0. So that makes it 1, 1, 0, 1. So if I do a division, I get or XOR, I get 1, 1, 1, 1. So I'll use it again. So 1, so 0 to the left. So this is 0, 0, 1, 0. So I think I used this 0 to bring it down, so I'll use this 0 now, and I get already 2 zeros to the left, so I have to skip them. So then I have one more 0 which I can make use of, so that's going to be 1, 1, 0, 1. So if I do XOR, it's going to be 0, 1, 0, 1. I can skip this 0 to the left, so after skip this 0, you get 101, which is 3 bits. That's your CRC. Okay, so this is your final CRC. Now if you don't get 3 bits, because from the generator polynomial we know the size of the CRC is going to 3 bits. This is the initial estimate, and this 101 is our final estimate. Now as a result of this XOR arithmetic, if you don't get 3 bits at the end like this, and you get only say 1 bit or 2 bit like this, so let's say you end up with just a 1, okay, as a result of a division, depends on the message, then you have to prefix 2 zeros to make it a 3-bit CRC, because we know the CRC is going to be of size 3 bits. Similarly, if you get something like 1 0 or something, then you prefix a 0 to make it a 3-bit CRC in this case, right? Okay, so that's the thing that you need to know. Okay, so take up any message and try to do an XOR division based, again choose a generated polynomial and see if what you get as CRC, and then actually, so what happens is, if say in this example this is your message, right? So let me continue further on this. So this is your message, so then what we got as CRC 101, right? So this is our CRC part, which is our CRC part, this is our CRC part. So now if you do an XOR division, with this generator polynomial 1101, okay, if you keep on doing this, you should get the final CRC to be what? All zeros, because now this CRC is part of the message, so that's because of the XOR arithmetic. You see 0 XORed with 0 is 0, right? So now this 0 XORed with this 0, you should get back this 0. Similarly, 0 XORed with 1 is 1, so this 1 XORed with this 1, you should get back this 0, right? So when you incorporate the CRC as part of the final CRC as part of your computation, then you should get when you do this reverse XOR arithmetic, you should get back this, right? So let's do that. So this is the original message that you wanted to send, and this is a CRC for that you have computed, and this is a generator polynomial. So let's do the XOR arithmetic one more time and see what do we get. So 1101, so the same thing like we did 1000, so you do again a 1101, so that's going to be 0 to the left and 101, so you can skip this 0 and you bring down which one? You bring down this one, okay, and that's going to be a 1, so that's 1101. So if you do an XOR arithmetic on that, it's going to be 0110, so you can skip this 0, then bring down this one, and you have 1101, the entire thing is matching, right? We encountered this before. So what we do is we will bring down these 4 bits, so that will be 0 0 1 1, so 1101, we do an XOR arithmetic, that's going to be 1110, so keep going, 1101, that's going to be 0011, right? So you can skip these 2 zeros, so you have 1 1. So we used this 1 came from here, so now we'll use these 2 bits 0 1, so that's going to be 0 1. So you have the generator polynomial is also 1101, so if you use 1101, you will get all zeros now, right? This is what we want. So if you get all zeros, then it means the message came without any corruption. Okay.